Okay, so the first two problems are for figuring out what quadrant angles are in. So the easiest way to do this is to remember what angle values define the coordinate directions. So you've got 0, pi over 2, pi, 3 pi divided by 2. So all you have to do is look at these and figure out where they fit. So for problem number 1, you've got pi divided by 5, which is 1/5 pi. And you see that the first quadrant, which is here, so let's put our quadrants on there. The first quadrant is between 0 and half a pi. So a fourth, since a fifth is greater than 0 but less than a half, it's going to be quadrant 1. Okay, B, 7 pi over 5. So what we have to do is compare 7/5 and figure out where that fits. So 7/5 is greater than 1, so it's going to be, well, 1 pi. So what I'm doing is looking at the fraction in front of the pi. So this is 1 pi. Then the question is 7/5 greater than 1/2? Because 3/2 is 1/2. So you can plug it in your calculator, or you could think, well, what's half of 5? Well, half of 5 would be 2.5. So 7.5 over 5 would be 1.5. So this is true. As a consequence, it's in quadrant 3. Now, the next problem is -1. Now this is not in terms of pi. So the other way you could think about this is you could either convert this to some value pi related to pi, or you could convert these numbers to decimals. If pi is 3.14, so pi over 2 is going to be 1.57, and this is going to be this plus that, which is 4.71, I think. And this would be 0. Okay. So that's one thing you could do. So you've got one radian is between 0 and 1.57. Now the thing is, it goes the other direction. So instead of going counterclockwise, you go clockwise. So if you went, say here's 1 radian, if you go -1, that's going to put you in quadrant 4. And here's another negative. So the one way with dealing with negatives is you can do it positive and then just flip it over the x-axis. So if you do 11 pi over 9, so let's do A. So part B. So if we did just 11 pi over 9, so we would go, so again the question is, where does 11/9 fit in? And this is a multiple of pi, so we can use the original thing. So this is 1 pi, this is 1.5 pi, and you can see that this is going to 11/9. If you plug it into your calculator, you'll get some number between 1 and 1.5. So it's in quadrant 3. So that's here. Now if you do the minus part, instead of going around this way, you go around that way. So it just moves you, it gives you that x-axis reflection. So in this case the answer would be quadrant 2. So that's kind of the logic you have to think about. You do have to remember that the coordinate axes are pi over 2, pi, 3 pi over 2. And then look at what fractions you have. And if those fractions multiplied by pi put you in a certain coordinate, then, and if it's positive, then you just stick it in that coordinate quadrant. if you do a negative, you can do the positive and then flip it over. So if it's negative and you end up in the positive version is in quadrant 3, then the negative version is going to be in quadrant 2. If it's in quadrant 4, then it'll go to quadrant 1. Okay, sketch each angle in standard position. So standard position means relative to the x-axis, positive x-axis being 0. So what we're going to do is we're going to draw our coordinate axes again here. Now, we have to be a little more accurate in this case. We could tell you what quadrants they're in, just as we did in the previous 2 problems. But we need to know where it fits. So if we looked at, let's just look at the quadrant first. So you've got negative 7 pi over 4. So let's do 7 pi over 4. So so this is 3a. So we're going to do 7 pi over 4, and then we're going to flip it over the x-axis. So what we're looking for is 7/4. Where does that fit? Well, 7/4 is more than 1. Actually, it's more than 1.5. So it's more than 1.5 and less than 2. 2 would be going all the way around. So again, if you plug that 7/4 in your calculator, you'll get 1.75, which is in this quadrant. So that gives you in quadrant, it's going to be in quadrant 4, but ultimately we're going to flip it over the x-axis because it's negative. So this will end up being in quadrant 1, because now where in quadrant 4 would this be? Well, what you have to think about is, where is it relative to the coordinate axes? This is 3 pi over 2, and if you keep going, this is 2 pi. So where in the range from 3/2 to 2 is 7/4? Because you can go 1/6 of the way. 1/6. You can go not 1/6, but you can break it into thirds. So let me break it into 3, and then we'll break it into a half. So if you break it into 3 parts, and each part is 1/6, so this is going to be 3/2 plus 1/6. This will be 3/2 plus 2/6. This is 3/2 plus 3/6. 3/6 is a half, so 3/2 plus a half is 2. Okay, so if you get a common denominator of 6, you're going to multiply that by 3, each one by 3, so you get 9/6 plus 1/6. That's 10/6. Here you'll have 9/6 plus 2/6, which is 11/6. And then if you break it in half, instead of going in sixths, you go in fourths. So bring this down here. This will be 3/2 plus 1/4, which is, if we make that into a 4 denominator, you'll have 6/4 plus 1/4, which is 7/4. Okay, so that's what we're looking for. So what that means is our angle 7 pi over 4 is right in the middle. If it was 10 pi over 6 or 5 pi over 3, it would go in a third of the way from here to here. And then if you do the next one, which is 11 pi over 6, that would go somewhere here. Because you can break it up into the coordinate axes and then the 3 major ones, which are either halfway in between or a third of the way, and then 2/3 of the way. Okay, so this one is 7 pi over 4. So if we now go the other direction, flip it over the x-axis because of the negative sign in front of it, it becomes that. So this is negative 7 pi over 4. And let's just show how this works. So if I go this way counterclockwise to here, that's 7 pi over 4. If I go the other way, so starting here but go negative the same amount of rotation, then I end up there. So the answer is this one right there. And this also is the same. It's coterminal with pi over 4. If I go this way, if I go counterclockwise, pi over 4 is the same as going negative 7 pi over 4 in terms of this position. Okay, so let's do the next one. Okay, so we just need to delete these things from there. Okay, 5 pi over 2. Well, let's see what 5 pi over 2 is. Well, it looks 5 halves. Well, 5 halves is greater than 2, so that means we go around a whole time, and then we go another half. So you go 5 pi over 2, because it's more than one rotation, becomes 2 pi. So it's 4 pi over 2 is 2 pi. And then you add 1 pi over 2. So 2 pi is 4 pi over 2. 4 pi over 2 plus 1 pi over 2 is 5 pi over 2. So this part brings us back, go counterclockwise back to here, and then we go another turn. So the answer for B is just that angle between the positive x-axis and there. So what we say is that 5 pi over 2, 5 pi over 2 and pi over 2 are coterminal. Because they have the same relative position between the positive x-axis and the other ray that defines the angle. Okay, let's erase that one, and I need to get rid of those. Let's just get rid of that one because we can leave this one here. Okay, so number 4 is 11 pi over 6. Well, we did that one earlier, if you remember. 11 pi over 6. Where is that relative to these coordinate directions? Well, it's greater than 3 halves, I think. No, it's not. Actually, it's greater than, it's not quite 2. 12 over 6 would be 2. So it is between 3 halves and 2. So it's going to be in this quadrant again. It's not negative, so we just have to go around that amount. And what we said, again, remember we did this, we said if you break this up into 3 parts, this, you go a third of the way, and then you go another third of the way, so that these angles are the same. This one will be 3 pi over 2 plus 1/6, and this one will be 3 pi over 2 plus 2/6. And if you do that, you'll have 9. So we want to get a common denominator of 6. So you get 9 plus 2, which is 11 pi over 6. So this is the angle. The one that goes all the way around like that. This one would be 10 pi over 6, which simplifies down to 5 pi over 3. Anyway, that's the correct one there. Okay, let's erase all that stuff. I should have erased that 3 pi over 2 thing. Now the next one is a little more problematic because it's not a percent of pi, but we could do that. So this is 4b. So if you take -3, you multiply by pi and you divide by pi. So what we'll do is we're multiplying by 1, and then we come up with the equivalent, decimal equivalent of 3 divided by pi. So let's write that out. 3 divided by 3.14159. So that's negative 0.955 pi. So again, what we'll do is we'll go positive plus 0.955 pi, and then we'll flip it over the x-axis. So this is 1 pi. This is 0.995 pi. So the positive version is going to be, we don't have to be exact. It's going to just be close to the 1. And then if you flip it over, reflect it over the x-axis, then that's it. And you're measuring this angle from here. This is -3 radians, which is negative 0.955 pi. So instead of going a full 1 pi clockwise, we go almost a full one. Okay, so this is an example of what we just kind of did earlier. We want to write these as a multiple of pi, so all you have to do, these are pretty easy, because you just have to do the calculation. So if you want to go from degrees to radians, well, yeah, that's the thing. First we got to go to radians, and then we got to make it some ratio of pi. So if you want to convert from degrees to radians, you multiply by pi and divide by 180. And what you can see is that if I do that approach, I can group the two integer parts together. And when I do that, I simplify that fraction, it'll be 1/6. You can divide this by 30 and this by 30. So you get 1/6 pi. So that's the multiple of pi approach. You can do the same thing for 150. 150 degrees times, and let's put a little degree there, degree, so degrees cancel out. So you get 150 times pi divided by 180 degrees. Again, they both have a common factor of 30, so you get 5/6 pi. Sometimes we say that's 5 pi divided by 6, 5 times pi divided by 6. Same thing here, pi divided by 6 instead of 1/6 pi. Okay, next, 20 degrees. So -20 degrees times pi divided by 180 degrees. Here the common factor is 20, so you get 1/9. So you get -1/9 pi, or -pi/9. And that's A. Same thing with B. So you get -240 degrees times pi divided by 180 degrees. So here we have a common factor of 30. So you'll get -8/6 pi. Actually, this is a common factor of 60. But 30 works, and then we can simplify it down. So you get -8/6 pi divided by 2 in both the numerator and denominator, so you get -4/3 pi, or -4 pi/3. Now here, what we're doing is, because we're looking at a decimal answer and they're not nice multiples of things, it's just a simple matter of taking this, multiplying by pi, but instead of keeping it as pi, we're going to use the numerical equivalent of pi divided by 180. So you take 87.4 times 3.14159, or if you have pi in your calculator, put pi in there, and divide by 180. And I get 1.53 radians. So that's not a multiple of pi, it's just the radian answer. And you do the same thing down here. So you take 48.27 degrees multiplied by pi divided by 180. So 48.27 times pi, 3.14159 divided by 180, and you get negative 0.842 radians. Okay, and then we can go the other way. Here it says do not use a calculator. So we're going to use that conversion, except we're going to do it the opposite way. So you'll have 3 pi divided by 2 times 180 degrees divided by pi. And you'll see that the pi's cancel out. And so you get 3 times 180 divided by 2, and you get 270 degrees. Okay, B, 7 pi divided by 6 multiplied by 180 degrees divided by pi. The pi's cancel out. So then you have 7 times 180, 7 times 180 divided by 6, and you get 210 degrees. Another way would have been to take each one of these and divide by 6. So 6 divided by 6 is 1, 180 divided by 6 is 30, 30 times 7 is 210. Okay, then we have negative 7 pi over 12 multiplied by 180 degrees divided by pi. Pi's cancel out. Again, you could simplify this, but let's just stick it in your calculator. So you get negative 7 times 180 divided by 12, and we get a negative 105 degrees. And then we have pi over 9. We'll multiply by 180 degrees per pi radians. The pi's cancel out. 180 divided by 6 is 30 degrees. Actually, it says do not use a calculator. I guess we did, yeah. I used the calculator after I canceled out pi. They just don't want you to put pi in there. Convert the measure from radians to degrees. Round to 3 decimal places. Okay, so same thing, except we actually do put pi in there. Well, we don't have to, because we can, in this case we can still cancel them out. So let's take 180 times 15 divided by 8 and 338 degrees. It's actually 337.5, but it says round to 3 decimal points. Same thing here. Multiply by 180 degrees. So negative 0.57 times 180 divided by pi, which I actually do have to use pi because the original one didn't have pi in it. So you get negative 32.7 degrees. Find the length of the arc on a circle of radius r intercepted by the central angle. So what we're doing here is we are kind of using the whole concept of what radians came from. So we're going to have a circle of radius 15. So let's say that's a radius of 15 inches. And we want to have a theta of 123 degrees. So we just have to sketch it in there. It doesn't have to be exact. Remember, this is 90. This is 180. So halfway between would be 135. So this is 123. So it's going to be somewhere not halfway. That's 135. So maybe about that. So what we're looking for is the length of this arc from here to there, And the arc length, S, so that's the distance along the arc, is equal to the radius times the angle in radians. So what we would do is we take 15 inches, the radius, and we have theta, this is in degrees, so we have to convert that to radians. So we multiply by pi and divide by 180. Radians are always a lot smaller than degrees, so pi is 3, divided by a big number, 180. So we have 15 times 123 degrees times pi divided by 180, which is 32.2 inches. Make sure you put your units on there. Okay. Same deal here on the second one, just a different diameter. Well, it's a different angle too. So you have a circle of radius 3 meters. So this distance here is 3 meters. This angle is 7 pi over 5. So what is 7/5? Let's take it. 7 divided by 5, it's 1.4. So remember, this is 1 pi, this is 1.5 pi, so it's going to be closer to this one than it is to that. So I'm just going to draw it like that. That's the angle. This angle here is going to be 7 pi over 5. And it's already in radians, so we don't have to convert things, which is nice. And the arc length we're talking about is this arc length that goes all the way around like that. Now, if we went all the way around, the arc length would be the circumference. This is going to be less. So again, the arc length is equal to the radius times the angle in radians, but it's already in radians, so we don't have to. So we just take 3 meters times 7 pi divided by 5 radians. Radians don't have units. They're just meters per meter, inch per inch, distance per distance. So we take 3 times 7 times pi divided by 5. And we get 13.2. Something doesn't look right. 3 times 7 times pi divided by 5. Well, I guess that is right. It's just, so, you know, going halfway around is this times pi, which is going to be, it's going to be 9 something. You know, 3 times 3.14159. It's almost 9.4. So to go to here is 9.4. If we went all the way around, it would be 18.8. And you got to put the units on there, meters. The radians, once you've used the angle in radians, you can drop those units. Okay, the next one is find the distance between the cities assuming that Earth is a sphere of radius 4,000 meters. So it's the same basic idea, except they've given you the angle in radians, minutes, and seconds. So what you need to do is convert you can convert these to decimals and then subtract them, or you could subtract them and then convert them to decimals. And let's do both of them just to show you how it works. So the way you convert 32 degrees, 47 minutes, 9 seconds, you take 32 plus 47 divided by 60 plus 9 divided by 3600, which is 60 times 60. Okay, so you take 32 plus 47 divided by 60 plus 9 divided by 60, divided by 3600, and we get 32.7858 degrees. And then you take 41 degrees, 15 minutes, 42 seconds. So that's 41 plus 15 divided by 60 plus 42 divided by 3600. 41 plus 15 divided by 60 plus 42 divided by 3600. So you get 41.2617 degrees. So my change in angle, to find my arc length, all I have to do is take the radius times the angle which we go through. So the radius is 4,000 miles, and the difference is 41.2617 and 32.7858. Oh, and we got to convert it to radians. I forgot to do that. So that's one more thing I've got to add on here. So let's do that. So that, not add on, but I've got to multiply by pi and divide by 180. The reason I knew I did something wrong, my number was just way too big. I'm like, what did I do wrong? Okay, so I got to take my answer, multiply by pi, divide by 180, 591 miles, 92 miles if you round up. Now the other way of doing it would be to take the difference of these two. So if you take 41 degrees, 15 minutes, 42 seconds minus 32 degrees, 47 minutes, 9 seconds. How does that work? Well, this way it works normally. So you have 42 minus 9 is 33. Here you have to borrow. So you're not borrowing 1, you're going to borrow 660. So we're going to take, there's 60 minutes per degree, so this becomes 40 instead of 41. So I take one of those, 60 of those, and then now I can subtract. So you get 60 minus 47, which is 13 minutes, and then 40 minus 32, which is 8. So you get 8 degrees, 13 minutes, 32 seconds. And then we can convert that difference to degrees. So you take 8 plus 13 divided by 60 plus 33 divided by 3600. So 8 plus 13 divided by 60 plus 33 divided by 3600. And I get 8.226 degrees. And then to find the distance, I take r times theta, but I'm going to have to convert this to radians, but I'll do that in a second. So you still got 4,000 miles times 8.226 degrees times pi divided by 180. That gets that degrees into radians. So you get 4,000 times 8.226 times pi divided by 180. And I don't think I got the same answer. Here I got 574. It's not. Let's just double check here. 41.2617 minus 32.78. Okay, I think I figured out what it was. So it's here. So it's, you add 60 plus 15, which is 75. So we get 75 minus 47. It's 28. And put that in there, 28. So at least I did it right the first time. Just messed it up the second time. So you get 8.4, 443. Plug that in here. Okay, so times 4,000 times pi divided by 180, 589. Okay, so that's just round off air, 589 miles. Okay, so you can either convert, it seems like converting the decimals first is easier instead of trying to do this subtraction. Okay, and then, oh, we got more stuff here. Car is moving at a rate of 65 miles per hour. The diameter of the wheels is 3.5 feet. Find the number of revolutions per minute the wheel is rotating. So we have this relationship between arc length and angle. There's also this relationship between speed and angular speed. So what we have is what we're going to do is we're going to convert this miles per hour to feet per minute, because they're asking for revolutions per minute, and they're giving us the diameter of the wheel in feet. So we need, the radius will be half the diameter, so that's half of 2.5 is 1.25 feet. And let's convert 65 miles per hour to, we want feet per minute. So how many minutes per hour? There are 60 minutes per hour, per 1 hour. Now I'm doing the denominator first because I'm trying to cancel out the hours so I get minutes in the denominator. So that'll work. Now I have hours cancel out, I have minutes. And then I have to do feet per mile. There are 5,280 feet per mile. You just have to look that up. So 65 times 5280 divided by 60 is 5,720 feet per minute. Okay, so that's the speed of the car. Now what we're going to try to do, we're going to calculate this rotational speed. So if you divide the velocity by the radius, so the velocity is 5,720 feet per minute, and you divide by 1.25 feet. So you get 5,720 divided by 1.25, which is 4,576. You can see the things cancel out. So that is radians per, because we don't have units here, radians per minute. There are 2 pi radians per 1 revolution. So the rotational speed is going to be 4,576 radians per minute divided by 2 pi radians per revolution. And so that comes out to be 723 revolutions per minute for the wheel. And we almost got the angular speed in radians per minute. What we ended up with was, oh no, we did. Actually, we already did that. So we solved that ahead of time. So that's the angular, what do they call it here? Make sure I'm using the same angular speed of the wheels. So the angular speed is 4,576 radians per minute, which is 722 revolutions per minute. And final one. The radius of a disk on a hard drive is 1.68 inches. That's the radius. Find the linear speed in feet per second of a point on the circumference of the disk if it is rotating at a speed of 7,200 revolutions per minute. So we just said that the linear speed is equal to the angular speed times the radius. Now, here we want to find the linear speed in feet per second. So first thing we have to do is convert the radius to feet. So we're going to divide by 12 inches per foot. So the inches cancel out and you get radius in feet. 1.68 divided by 12 is 0.14 feet. And we have the speed in 7,200 revolutions per minute. And we need to convert that to radians per second to make this thing work out for angular speed to be right. So we're going to have 60 seconds per 1 minute. And then we multiply it by 2 pi. There's 2 pi radians per revolution. So the revolutions cancel out, the minutes cancel out. We end up with radians per second. So 7,200 times 2 divided by pi times 2 pi, not divided by, times 2 times pi, divided by 1 by 60. So that's 753 radians per second. So the linear speed in feet per minute, feet per second, is going to be 753 radians per second times 0.14 feet. So we get 105 feet per second. Radians don't have units, so we can ignore those after we've done this. So that is the answer.